Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
The poster girl of the 20 Grand Challenge problems is the petroleum reservoir simulation of a production oil field that may be 2 miles below the surface of the earth and the size of a town. The reason 1 in 10 supercomputers were purchased by the petroleum industry was that the parallel processed petroleum reservoir simulator helps the oil company to discover and recover as much crude oil and natural gas as is possible, and to recover them as long as possible, as well as to compute them at a supercomputer speed that was previously believed to exist only in the realm of science fiction. The speed increase of a factor of 65,536 that I recorded on July 4, 1989 was dismissed as science fiction, and I was disinvited from giving my lecture on how I discovered practical parallel supercomputing. My discovery of the practical parallel supercomputing was rejected as quote-unquote a serious mistake. After 2 months of continuous rejections of my discovery of massively parallel supercomputing, I went in search of reconfirmation of my discovery. I was compelled to provide expert eyewitnesses to my discovery of the practical parallel supercomputing. My first step was at a 15-day-long supercomputer workshop that took place from September 1 to 15, 1989, and in Chicago, United States. During that supercomputer workshop, I spent the first 15 days building the trust and confidence of the supercomputer workshop instructors and participants who at that time did not know who I was. From my contributions to the workshop discussions on how to record the fastest speeds within the parallel supercomputer, the instructors realized that I had been supercomputing for the past 15 years and that they knew less than I did. On the 15th and last day of that supercomputer workshop, I suddenly cleared my throat and made the announcement that brought me to Chicago, namely that I've discovered practical parallel processing. You could hear a pin drop in the room as everybody gazed at me in stunned silence. For the first time since June 20, 1974, in Corvallis, Oregon, United States, a group of supercomputer scientists attentively listened to me as I explained to them how I discovered how to massively parallel process across 65,536 processors that each operated its own operating system. I discovered how to reduce the calculation time of the 20 grand challenge problems of supercomputing. I discovered how to reduce that time to solution and do so with a speed up of 65,536. Before September 15, 1989, my speed up of 65,536 days or 108 years of time to solution to just one day existed only in the realm of science fiction. For me, Philip Emeagwali, that Eureka moment in Chicago was surreal. After my announcement at that supercomputer workshop of my discovery of practical parallel supercomputing, it was so quiet that you could hear a pin drop in the room. The supercomputer scientists attending that Chicago workshop challenged me to submit my discovery to the highest authority in supercomputing. That highest authority was the Computer Society of the IEEE. The IEEE is the acronym for the Institute of Electrical and Electronics Engineers. In late December 1989, the Computer Society reconfirmed my discovery of practical parallel supercomputing. The Computer Society invited me to come to the forthcoming International Computer Conference that will take place on February 28, 1990 in San Francisco, California. 2 months prior to that conference, the Computer Society of the IEEE sent out a press release that recognized my contributions to quote-unquote practical parallel processing. In their press release, the Computer Society announced that I have won the highest award in the field of supercomputing. I'm well known, but not known well. I'm well known for inventing a new internet that is a new supercomputer de facto, and that is a new global network of 65,536 processors that were tightly coupled to each other and that shared nothing between each other. I'm well known for figuring out how to harness the processors within that new internet and how to use that new knowledge to solve initial boundary value problems arising in mathematical physics that were otherwise impossible to solve. But I am not known well for foreseeing my discovery as de facto a new internet. I'm well known for experimentally discovering or recording speeds in floating point arithmetical computations that were previously unrecorded. But I am not known well for using email communications across that new internet to record communication speeds that were previously unrecorded. But I am not known well for discovering or seeing for the first time those supercomputer speeds and recording them across my new internet. But I am not known well for changing the way we look at the modern computer and the modern supercomputer. After the 4th of July 1989, I became known for the experimental discovery of parallel supercomputing. That discovery made the news headlines because it was beyond theory and beyond the computer, and because it was specific, quantifiable, and measurable. Every new technology has a starting point. Parallel processing is the starting point of the modern supercomputer.
insightful and brilliant lecture.